Okay, so next I want to talk about the effects of climate change. I told you the climate change topic was pretty long, but we're finally to looking at how affects ecosystems and biodiversity. So that's what we're going to talk about next. So we see that sea ice is disappearing. The fabled Northwest Passage of people looking for a way to take a boat from Europe to Asia over the top is opening up. In the past, they couldn't get through because there was too much ice. In 2016 to 2017, the sea ice was at its lowest recorded levels. And we see glaciers retreating all over the world, and I'll show you some pictures of that. We find that permafrost is thawing. This is ground that it's called permafrost because it's permanently frozen ground. Is becoming not permanently frozen in Alaska and Canada, as well as in Siberia and other cold places around the world. We find that the oceans are absorbing and storing more heat. As the temperature increases, we get coral bleaching, which I'll talk some more about later on. And we're starting to see sea level rise already in the last century. Most of this is due to melting land ice. So there was water frozen on land. As it melts, it flows off. It makes the sea level go up. We also see a little bit from thermal expansion, which is that we see that warmer things get bigger. They take up more space. And so that's part of it as the ocean gets bigger as it's warmer. But we won't spend a lot of time talking about that. So sea ice is melting, and unfortunately this creates a positive feedback loop. So you've probably heard of a negative feedback loop, like in your body. So if your body gets too warm, you start sweating, and then as the sweat starts to evaporate, your body temperature starts to go down. Or if your body temperature goes down too far, you start shivering, which generates heat, which brings your body back up. So this is a negative feedback loop. It means when you go too far in one direction, your body does something to bring you back to the normal level. So if you get too high, it does something to bring you down. If you get too low, it does something to bring you back up. A positive feedback loop is the opposite. What happens is when something changes a little, that triggers another change that makes it change more instead of come back to normal. So what we see here is that the sea ice is melting, and we talked about how ice and snow are extremely reflective and are good at reflecting sunlight back out into space. As the sea ice melts, more of the surface of the Earth is this darker blue color, which has a much lower albedo, which means it absorbs more of the sun's energy and turns it into heat, which makes climate change worse, which makes more ice and snow melt, which makes more water, which absorbs more heat. You can see that's a positive feedback loop. It goes on. And there are a lot of problems with walrus having places to go, and so this picture shows that. There are problems with polar bears, which is probably the most famous example you've heard, because they rely on this sea ice to be able to hunt seals. We see surface melting on Greenland is taking up more and more space each year. So this is Greenland. Greenland has a ton of ice on it. It is a very large island. And you can see this is the ice expanse and the amount of areas that are melting in 1992, in 2002, and 2005. And so there is a lot of water coming off of Greenland. And that is a problem for sea level. We see disappearing glaciers. And I will put the video for Glacier National Park in for you to look at next. Glaciers are disappearing from Glacier National Park. They're expected to disappear by 2030, so in less than 10 years, which means that Glacier National Park will no longer be named. It will be named for glaciers that are no longer there. So this shows a glacier in Alaska. And you can see the expanse of ice. This is exactly the same picture. So you can see this mountain here, this mountain here, this mountain back here, this mountain back here. These glaciers are gone. And the video will show some similar kinds of pictures from Glacier National Park in Montana. All of this melting ice, that ice melt, this has been a controversy a little bit. Sea ice melting doesn't really cause much change in sea level. It's the same kind of idea, like if you have ice cubes in your water, as the ice melts, your water glass doesn't overflow. So the floating sea ice isn't really the problem. The problem is all the ice on land that's not in the water. As it melts, it brings up the sea level. And so that's exactly what we've been seeing. So this shows the change in sea level over time from 1994 to about 2006. And we can see that there has been a continual increase, and it's expected to continue through time. These are the projected sea level rises by 2100. Miami is working actively to pump water out of the city. They're already pumping water out. They have what's called sunny day flooding. It's when there is no rain. There's just water coming up through the grates in the middle of the city. And they've had to install pumps to keep that from happening. And it's from sea level rise. And so Miami's been working actively on plans to deal with climate change. New Orleans is going to need to do the same thing. So these are our two most vulnerable coasts. Miami, a lot of the areas around Miami, the Keys, and the Everglades are projected to be underwater by 2100. Miami itself should partially be okay for that point, but it depends on how much more warming we get after that. You can see that we're projected to lose a lot of the coastline of Louisiana. New Orleans is on a slight bit of high ground, but these are very important areas that protect a lot of the state from storm surge during hurricanes. And we had a lot of hurricanes this last hurricane season. So we really need this land area there. So dealing and planning for climate change is going to be very important for our state. Effects of global warming, we're expecting more extreme weather, including droughts, floods, heat waves, and hurricanes. I mentioned before that climate change or global warming is expected to increase climate variability. With that comes these more just different extremes. And these could have very large economic and human costs. Estimates published in 2009 project a sea level rise of 0.6 meters, and this would flood low-lying coastal cities like New Orleans, Miami, Boston, New York, London, and Mumbai. You can imagine the number of people that could be displaced by that would be amazing. We've had a lot of problems with refugees from Syria and other countries like that. There's most likely a climate portion of that equation. The amount of refugees we would have if New Orleans, Miami, Boston, New York, London, and Mumbai all were underwater, that would be a lot of people that need new places to go, and the refugee crisis would be incredible. So the melting of glacial ice caps in Greenland and Antarctica could raise the global sea levels 100 meters. So hopefully not all of that ice would melt. That probably would not happen in any of our lifetimes, but it could happen eventually. Insurance companies are really concerned about this, and they're not insuring. They're not giving out a lot of flood insurance anymore, especially if you live on the coast. And so this shows the vulnerability to sea level map, and you can see the entire state of Louisiana is red in the very highly vulnerable level. And there are some parts of the coast that are have lower vulnerability, and some parts that have higher. We know that these changes are already causing harm in Louisiana and Texas, especially if you're from Houston. You know how problematic flooding can be and how much of an economic and personal cost flooding can cause. And so this shows the number of major floods per decade, and they've been increasing everywhere. You can see in the Americas, they've increased a lot. In Asia, they've really increased a lot. But we see the same thing in Africa and Europe as well. Harm is already occurring. We had a crazy hurricane season this last year. This shows the correlation between tropical cyclones, hurricanes, pretty much the same, and increased sea surface temperatures. So as temperatures get warmer, we get more intense storms. So we're more likely to get the category 4s, category 5s, with hotter ocean temperatures. And so climate change is expected to make hurricane and cyclone more intense and more of them. And so we know all about that. That is not something we really want to deal with. This is a slide I added in last year in response to the fires in Australia. So last winter, Australia was extremely hot, and a lot of it was on fire. If you'll remember, our fun start to 2020, even worse if you lived in Australia. Thank goodness we didn't have giant fires where we are, but of course California did. They had crazy hot temperatures, like record temperatures. They had areas that exceeded 45 degrees Celsius. That's way over 100 degrees, so really hot. That plus a drought created the perfect conditions for these fires. And an estimated 10 million hectares had burned as of July 13th. I probably should have updated this, but you can at least see the pictures. It could be seen from space. We had smoke go all the way around the world. This is a product of climate change. These extreme fires, extreme droughts are much more likely with climate change. As it's hotter, these kinds of things are more likely to occur. We also are seeing that as we have more droughts, our forests are more vulnerable to insect pests, which often make them more vulnerable then to catastrophic wildfires. I'm not talking about little tiny fires. I'm talking about big, scorching wildfires that burn the forest to the ground, not prescribed fires or low-intensity fires that are good for some ecosystems, but these really big fires that burn almost everything in their path. This is a quote from a scientist at the University of East Anglia. Overall, the 57 papers reviewed clearly show human-induced warming has already led to a global increase in the frequency and severity of fire weather, increasing the risks of wildfire. All right, so we want to think about some more. Those are some obvious effects that are going to affect conservation biology and affect biodiversity. If a catastrophic wildfire comes through, biodiversity is going to go down, obviously. If an area that is terrestrial is flooded by sea level rise, biodiversity is going to go down in those areas. But there are other more subtle effects. We see that growing seasons are lengthening in the northern hemisphere. Some animals are changing the timing of when they do things and where they go. And some animals are disappearing from climate change already. One of the poster species for this is the American pika that lives up in a rock talus environment, which is like stacked rocks on top of mountains that we see at the top of the Rocky Mountains. And there are these little rodents that collect plants and make hay, and they live way on the top of the Rocky Mountains. And they're very vulnerable to heat stress. So they're one of the things that are expected to be very much affected by climate change. We see droughts are more frequent, widespread, storms are more severe. That's going to affect biodiversity. Animals are changing when and where they move, when they breed, all these different kinds of things. And one thing that's a concern with that is that there will be a mismatch between predators and prey, or species and their resources. And if that happens, that could make their populations vulnerable. Some species are declining or going extinct due to warming temperatures, but also loss of habitat. I wanted to show this little map right here. This shows one thing that people have been working on is looking at the climate where a species is now, and then looking at the projected climate in the future and seeing where that species is going to be able to live in the future. And so this is one of those for sugar maple, which is an important forest species of tree for us in the United States, but it's also important for economics because it's the source of maple syrup. And so you can see that the yellow is their present range, the blue is their projected range, and the green is the overlap. And so these are two different models here, and you can see that the projections are a little bit different. One of the other effects is thawing permafrost. And so permafrost is that land that's supposed to stay frozen all the time. Unfortunately, there's a lot of methane stored inside permafrost. And as it thaws, that methane is released. And if you remember, methane is a greenhouse gas and a pretty powerful one. So this is another one of those positive feedback loops where as it gets warmer, the permafrost thaws, which releases more methane, which causes more warming, which thaws more permafrost, which causes more methane, which causes more warming. Positive feedback loops, not what we want. Unfortunately, our climate change models are not perfect, and we don't know how much methane is stored in the permafrost. So this is one of the areas where the climate change models need to be improved. Because we don't have a good handle on this inside these models. The next one I wanted to talk about is coral bleaching, and some of you guys are probably really familiar with this, especially if any of you took Dr. Stake's class on coral bleaching or one of Dr. Hill's marine biology courses. And this is kind of the basics about how coral bleaching occurs. It can happen anytime coral becomes stressed. If you'll remember when we were talking about mutualisms, coral is an example of a mutualism. So the coral is an animal, but inside the coral's cells is an algae that does photosynthesis and provides sugars. It also is the source of the color for the coral. When coral gets stressed, and it can get stressed by a few different ways, but recently a big way it's been stressed is by warming ocean temperatures. This coral gets stressed, and it basically spits the algae out. The coral's like freaking out because something's wrong. It spits the algae out, and the algae is the source of the color, so it turns white. When it's bright white, it's usually not dead yet. The coral's still alive. It's just lacking its symbiotic partner, the algae, the zooxanthellae. But if it bleaches for too long, they'll die. If it's a really short amount of time, sometimes they can get their algae partners back and become a functioning coral again. But most of the time, it's permanent, and then the coral dies after that. And coral reefs are really, really important biodiversity hotspots. They're important nurseries for a lot of our commercial fisheries. So this has catastrophic implications for biodiversity, but also for commercial fishing.